In this video, we'll look at FIMMWAVE's bend solver, allowing us to calculate the mode loss as a function of curvature. So what we have here already open is an SOI ridge waveguide, and it's set to calculate using the FMM solver of FIMMWAVE, and we'll just look at the fundamental mode. So to calculate the mode, we select Build List, Start. And there's the mode there. You can see it's slightly off center, and that's because we're simulating this at a radius of 100 microns, which is not enough to produce any leakage from the core. But we can change that and see how it goes. So the first thing I'm going to do here is add a variables node just to make my life easier. And I'm going to create a variable called radius. And I'm going to give it a value of 100. And then once the variable is defined here, I can go into the settings here, and in the solver settings here, I defined H curve, which is the curvature, which is 1 over radius. And now it's controlled by my variable. And just to check we didn't change anything, I'll rebuild the mode again. And here we have the same mode. So now if I want to change this to, say, for example, 25, a radius of 25 microns. And also, because we now might be experiencing some loss, let's look at the boundary conditions. So, because we need an absorbing boundary condition on the outer edge of the bend. So I go to the Edit Waveguide. And currently I've got a PML, which is an absorbing layer, a PML perfectly matched layer. But we can go one step better when using the FMN solver, and we can switch the boundary condition to transparent, which effectively is like having an infinite PML layer. So now when I open the mode solver, the previously calculated mode for a radius of 100 microns already exists. But now we want to calculate for 25 micron radius. So when I click the Build List button, I'm actually going to select Polish. And what it will do, it will take the previously calculated result and refine it with the new model parameters. And the nice thing about that is it's a much quicker calculation. Building it from scratch, took maybe 4 or 5 seconds, and this took maybe 1 or 2 seconds. And there we see the mode for a radius of 25. You can see a lot more pressure on the outside of the bend, but still no leakage yet. And we can tell this from this number here, because this is the effective index of the mode. And if there's any mode loss, it would have an imaginary component, which it doesn't yet. So the question becomes, at what radius or curvature does this mode start leaking? And the way that we can quickly answer that question is by adding a waveguide scanner, so a WG scanner tool, to the model. And we're going to scan this waveguide, which is silicon rib bend. And we're going to scan the radius parameter. And we're going to scan it between 25, which is where we're at now, down to, let's say, 10 microns radius. And we'll do 16 steps, so we get 1 micron per step. And then to start the scan, from the top menu, Scan, Start. And what do we want to plot? Well, let's plot the mode loss as calculated from the imaginary part of the eigenvalue. So we'll add that to the list, and we'll click OK to start the scan. So you can see here dynamically the graph is updating as we step down the radius, and this is the mode loss in units of 1 per centimeter. And as we expect, as we get to a tighter radius, the mode loss is increasing quite noticeably. And at each step of this calculation, FIMMWAVE is automatically doing that polish routine using the previously calculated mode of that step and iterating to the next step. So therefore we get quite a speedy result here. And just to put that on full size, there's our graph of radius versus mode loss of the fundamental mode of this silicon rib waveguide.